So I guess our first question actually is, can you explain to everyone what is Octopus Energy?
Yeah, good question. So Octopus Energy now is quite a big group of companies. So I often get that question, what is Octopus Energy and what do we do? We are 8 years old as a group of companies, and we started really as an energy retail business. So the aim when we started was to disrupt the energy retail sector. We saw a sector that was really not serving customers in the UK, so very bad customer service outcomes, some slightly nasty pricing behaviors, and just generally not a great sort of customer experience. But we also saw a sector that was basically the delivery route for net zero. So the way we see it is that to get to net zero, you have to get customers on board. So you can't do this behind the scenes. We tried it, and we've done an amazing job, particularly in the UK, things like wind turbines and solar panels, and customers kind of didn't really know that was happening. You know, they could see them in off the coast, but they didn't know necessarily other than a little bit of extra cost on their bills. But now we're at the phase of net zero transition where we have to engage customers. We have to change the cars they drive. We have to change how we heat our homes, from sort of burning gas in our homes to using things like heat pumps. And that needs a delivery arm. And so we saw energy retail as the sort of way to deliver that. So having a relationship with the customer and then being able to take them on that journey from maybe buying some renewable energy to having a electric vehicle and a heat pump, and then letting us control that electric vehicle and heat pump so that it uses the most green energy at the most green times. And so effectively, all we do as a group of companies is aimed at delivering that net zero transition from a customer perspective. And so it kind of breaks down into energy retail. So we sell energy, we buy energy and we sell it to customers in, I think, 8 countries now around the world. We have a technology arm called Kraken. And the aim of Kraken is basically to be that platform, the operating system for a modern energy utility. And we license that to, I think, 50% of the UK market now, and a large chunk of the Australian market. We're making big inroads in Japan. The idea there is that you can't change an industry without changing like the sort of the software that it runs on, and the software was quite old and not really fit for purpose. So we built our own platform to do that. We have a generation arm where we build renewable generation. So we go out and invest in wind turbines, the hard stuff. And then we have a services business where we go out and actually literally go to people's homes in our Octopus branded vans and go and change meters and install heat pumps and electric vehicles. And we're trying to do that globally.
And can you tell us a bit more, what is the role of data in the transition to net zero?
To run an energy system, you need to have loads of data. You need to understand how much energy is being used at any time. You have to forecast that. You need to make sure you're dispatching the amount of energy you need at that point in time. And to do that requires a lot of data. And even in the old world where we had a few hundred power stations that National Grid could dispatch, and then demand was pretty predictable because everybody behaved the same, that was still quite data driven. In the new world where you've got all these electric vehicles which are doing different things and maybe being dispatched against price signals, and we have to balance the grid much lower in the grid because there's so much more demand at the end nodes. There's so much more data required. So we ingest vast amounts of data, both in our retail businesses, our generation businesses, flexibility business, and obviously within our software business. And it's crucial to making great decisions.
What would you say are the main sources of data? What are the largest and most complex ones that you have to deal with?
There's width and depth. The widest data sources, the data sources with the most tables and columns and the most sort of hierarchical complexity come from our platform Kraken, because it's like a full stack energy platform. It does everything from speaking to the meter all the way through to transcribing calls and doing clever AI stuff on it. So it literally every part of a customer journey is captured by Kraken. And so there's hundreds and hundreds of tables to ingest, and just getting all those tables into a data platform and making use of them is a challenge for our data engineering teams. And then the deep tables are things like smart meter data. So a smart meter spits out in the UK 48 readings, so one every half an hour. In Australia, one every 5 minutes. And so if you're running millions of customers on platform, it's not huge data compared to some of the stuff that some of the big tech giants do, but it is quite a lot of data, and getting that process is hard. And then soon we're starting to see that being overtaken by telemetry data. So data that's coming off us are wind turbines, or data that's coming off the electric vehicles and telling us I've plugged in, I've plugged out, I need to charge now. So yeah, we've had to, we re-platformed a while ago because we saw that change coming, just tsunami of data that we have to handle.
You mentioned earlier you wanted people using the most green energy at the most green times. Is that a fixed time, the most green times, or is that when your wind turbines are saying like, oh, it's really windy?
They do say that. It used to be a fixed time in the sense that you could predict that during 4 till 7 p.m., that's when most people come home, and statistics works in large numbers at a grid level. Like you kind of knew that like every day the big peak was going to be there, and that generally meant you're going to have to drive all the way up through your generation stack. So from nuclear, and then you're going to have to like bring on all of your thermal, so like your coal, and then all of your whatever renewables on at that point, and then maybe your gas, so diesel, and etc. all the way up. So you get to your dirtiest stack in the peak hours. Now it's actually much harder to predict when is going to be the greenest half an hour of the day. So you kind of know what the dirtiest time is. It's always going to be that peak period. But the cleanest time is harder to predict because it might be in the middle of the night when there's loads of wind on. In the summer, it might be in the middle of the day when there's loads of solar on the system. We've got a lot of installed solar in the UK. And I'm talking a bit of UK, but like it's very different in, say, Japan or in Australia where they've got this enormous solar load. So it's hard to predict, and being able to predict that and being able to move demand into that is extremely valuable for the customer, but it's also valuable for the utility.
How responsive is that? Let's say there's like an emergency government broadcast, everyone turns on their television at once. No one saw it coming. How quickly can you go, if it was just the wind turbines going, how does that work to go, let's say you need to go right up to the dirty sources, how quickly can that happen and how does that occur?
So, and just to be clear, like Octopus, like in each country there's a system operator, and the energy system operator in the UK, that's National Grid, and it's their job to dispatch all this.
Okay.
It's our job to provide them with the tools to do that. And what I mean by that is like traditionally their tools have been call up the biggest power station and turn it up, and they'll kind of plan for that in advance, but they'll also have a bunch of spinning reserve which they can just turn on and turn up. They've also got frequency response, which is like stuff which they don't even have to dispatch, it just reacts. And in what we realize is that like customers have a huge potential to flex, and they have even more potential to flex when they've got an electric vehicle, which is a giant battery sitting on their driveway. And they have even more potential to flex when they have an electric heat pump and their home, which is effectively a ginormous thermal battery. So what we're trying to do is find great customer propositions that can incentivize customers to flex, and then ways to be able to package that flex and sell it back to the system operator.
What do you mean by flex?
Flex is basically the ability to move load or sometimes destroy load, and generally it's moving load. So it's basically saying there's a bunch of load coming at peak time, we want to move that to the middle of the night. Like, how would you do that? And traditionally, the system operator wouldn't move load. So they would say demand is inflexible, was the thinking paradigm a few years ago, and generation is flexible. So you reshape your generation to match demand. In the world we see coming, and what the world we're designing our platforms and our businesses for, generation is harder to predict and more intermittent because it's coming from renewables, and demand is much more flexible, and you can dispatch it. And so we can take the idea is we can take like a bunch of EVs and move that EV load to the best, greenest time when there's the most power in the system, and it's best for the system operator, whilst also fulfilling the needs of the customer. And the needs of the customer might be, I just need my car charged by 6 a.m. So I don't care when I charge it. Is it midnight? Is it 9 p.m.? Is it 10 p.m.? Whatever.
That definitely makes sense. There must be a massive network effect here. And how hard do you find it to change consumer habits to try and get everyone doing that flexible model?
We were originally told that customers won't flex. You can't persuade a customer to change when they do their washing or their dishwasher. You can't persuade a customer to charge their car. We looked at like businesses which were ahead, or sectors which were ahead of the like digitalization curve, and realized that customers really do flex. So like it's a bit of a cliche, but Uber's an amazing analogy because they realized that if you give customers a very clear price signal with a nice UI and a very clear reward signal for like effectively the surge charge for not taking a taxi in a specific period or having to pay a premium for a busy period, they will firstly, the taxis will come to that area and that time, and also the customers will find other alternative routes. And so I guess we saw that and realized that a really simple incentive structure and a really nice UI were the two things that made this work. And so we've come up with a few options. We have smart tariffs where the price of energy you pay literally depends on.
I guess would not change their demand patterns. And do you think that started to change the perception in the industry?
I think the industry needed showing. So we took a lot of risk. We basically launched smart tariffs, where the pricing formula, like for our Agile one, we were sort of artificially at some point sending it below zero to do plunge pricing because we wanted to see what customers would do when prices were negative. And now we have a system where prices do go negative quite a lot. But the formula we put in meant that happened a bit more. And so, yeah, I think we felt like we needed to show the system. There were lots of people, by the way, who were already, in the industry saying, this could happen. So we kind of helped, I think, galvanize that. And the nice thing is that the system operators are really on board now. The network operators are really on board now. I think not just in the UK, but in like many countries, that they see the value of this. And for something like saving sessions, which is a national incentive, it's called the DFS, Demand Flexibility Service, I think. We now have loads and loads of suppliers taking part. And not just loads of suppliers, there are also now companies that aren't even energy suppliers that have like jumped on the bandwagon because they see the value in this business model and are doing the same thing.
Just I think that can you tell us a bit more about your team? Like, you have a great mission and your lead of data, and how many people do you have in your team? How you keep them productive, focused, and what are they enjoy doing?
Very good question. And defining team is sometimes hard. I think of it more like a community or a function now. And the way we organize is what I would call like platform, pods, and community. So platform is a central data platform team who provide all of the infrastructure that our data stuff runs on. And that is sort of tens of engineers and a mix of platform engineers and data engineers, so people building like actual cloud infrastructure versus people working in Databricks and building pipelines and deploying them. And then we have pods of people for each of our business unit, and then in the bigger business units, pods per like department. So in the retail business, we might have a finance and commercial pod, and that's a group of data scientists and data analysts, mixed discipline, who are embedded within the business unit, and their job is to go after those like specific business problems in that area. And then the community is like the thing I try and knit together, which is like, how do you make everyone feel part of like a data strategy and a group of data professionals who are really like awesome and ahead of and doing great stuff, and actually it's a fun place to work. And so we do that through like meetings and Slack channels and all that kind of stuff.
It's really interesting, particularly because Octopus Energy has been so fast growing. And how do you manage that as the team grows? Because it's great when you're all kind of like a small, close-knit group of people, but as the company scales very rapidly, did you encounter any challenges in trying to keep that culture?
Yeah, so it's worth saying I was the data team for a year or so. So I was the only data person in a startup of like 20 people. And now, so I sort of dodged your question about how many people are we, but I think when we get together, like globally across all of our business units, our like data function is like 50 to 100 people right now.
And it just started with you.
And it started with me, yeah. And so the way I see it is like, I think is in phases. So like phase one is like startup phase, and all you care about is solving like immediate burning business problems. You don't care about what tools you're using. You don't care about like whether you have development frameworks and team structures. When it was just me, there was no point in having development frameworks and team structures. All you care about is like the CEO has a growth problem. How do you solve that immediately in the quickest way possible? Then you go into like scale up phase where maybe we had a team of like 6 or 7 people. At that point, we started to focus a bit more on tooling, because you can't scale analytics beyond a few people unless you're using like shared repositories, version control, and also the data. You can't, like, if everybody's running different SQL queries on their machine, like what's the source of truth? So we started to think about like how do we maintain like consistent data pipelines. And then I'd say we're now at enterprise scale, and we're worried about like how do you organize the team to deliver across like a vast array of different business units? How do we make sure we have the right tools in place at scale with the data volumes? So that's when we started things like Databricks. How do you maintain a project with hundreds of data developers? So our DBT projects have like over 100 contributors. Our Databricks SQL warehouses have over 600 queries. So and it's like, it's a layering problem. So like your inner layer is your data team, your data platform team, your next layer is your data pods, and then your layer out is like all these people who are doing amazing things with data, like hundreds of them, but I can't see everything they're doing, and nor should I. And so how do you give them the tools, the training to like do the right thing and empower them without constraining them, but also without them creating a whole bunch of chaos? That's what I think is sort of the enterprise challenge now.
And I guess data governance came into question a lot.
Our approach has been, well, DBT, tooling has helped us a lot. So DBT helped us with massive data governance. And then Unity Catalog is helping us a lot now. A little shout out for Unity Catalog. Well, the big thing for me about data governance was like, when we were small, everybody, I used to get like endless emails from companies trying to sell me data governance. And I was like, and this was like sort of startup stage. I was like, I don't really know exactly what data governance is. But in my head, it was like something draconian, which meant like not doing things. And then I sort of started, when we started to hit like data governance challenges, which is the right table to use for this specific problem, or then we were like, actually, data governance is really an enabler. It's like a positive thing, not a negative thing. It's being able to see all of your data clearly, having one view of it, having owners so people know who to go to when there's a problem, having like really strong access controls so that you know that it's secure by design rather than secure by like somebody scrambling around to keep it secure. And once we hit that, we're like, okay, right, what's the tooling that we need to do that? And I think, yeah, as I said, DBT is great because it maintains all of your transformation in one place. And Unity Catalog is also really awesome because it's bringing together the sort of like user layer and the sort of asset layer. So the users, who's using it, and the assets, what are the tables in one platform, which really helps.
I find the example of data governance really interesting in terms of like how quickly you scaled and lesson you learned. And my follow-up question would be, if you were to look back now and you had like one grain of wisdom for someone in a similar like high growth first person in the data team in a startup, what would you say that you would have done differently or you would have considered differently?
I think there's some stuff which we probably should have got to earlier. So things like, I wish I'd known about DBT earlier because it would have just helped us. And I wish we went down a strategy of using like sort of Presto, Athena type tooling initially, which was great as like very high performance, very low cost, scalable compute, but it lacked that like data governance element or like just the organizational, like organizing your data sources. They've added a lot of stuff to it recently, which sort of bridges that gap. But I definitely think if we'd introduced those a bit earlier, we might have like staved off some of the issues. I also think it's almost easier and harder now as a startup because there's really well-established tooling now, sort of what people call the modern data stack. It's quite easy to be like, I know I'm safe buying Databricks or BigQuery or Snowflake, or even like a sort of DuckDB if you're small, plus a DBT or a SQL mesh, plus a sort of like visualization layer. I think when we were starting, some of that stuff was around, but it was like it was less clear, like this is exactly what you should choose and use. Although there's so many more tools now, that's probably like slightly choice paradox for people coming into the space.
Yeah, and that's really interesting actually. Like these modern data platforms are, as you say, like they're much more mature. But I think one thing that your team really puts emphasis on actually is like open source technologies. I was wondering, how do you kind of consider both of those? And like when you look to solve a problem, obviously you can get a data platform, but at the same time, you generally also want to innovate in your own ways. And how do you, when you're considering a tool for a solution, like how do you take into account open source versus proprietary data platform?
So my thesis, having been burnt a few times on choosing tools, is the engineers and the analysts and the scientists are going to be the ones working on it. It's not going to be me because I'm answering emails and doing meetings and trying to organize. And so generally the best tools we've had have been the ones chosen by the team and often promoted by the team. So like, hey, I think we should use this. DBT was a good example of that. Streamlit is another good example of one of the teams. They looked at a few things. I asked them to look at a few things, but they said, this is the one, we really like Streamlit. Let's use that. So yeah, I think like picking the tools that the teams like, and often engineers quite like open source because they can see under the hood. So yeah, we're like often looking to balance what the engineers want to use. And then obviously you have, is it enterprise grade? Does it have all the Okta integrations and security stuff that you need? But generally you can't go too far wrong if you like let the people using the tools pick the tools because ultimately they're working with them day to day.
Very democratic. I think that's actually quite unusual.
I don't know if my team will agree with whether I've lived up to that, but
we'll definitely forward this part of the podcast.
And can you tell us a bit more about data quality? Because I'm assuming if you're working on use cases such as like supply-demand signaling, having data quality issues can lead to very wrong results. So what is your approach? How you do this?
The problems with data quality, I actually think tend to arise typically in like what I'd call like the primary layer. So the source system, that's often where data quality is the biggest issue. And then that will roll all the way through to your data analytics layer. So all the way from ingestion through, if it's captured poorly or like is just wrong in that layer, you've already got an uphill challenge. We're quite lucky in that a lot of, particularly in the retail business, a lot of the data we ingest comes from a system that Kraken, that we as a group of businesses have built, and it's really well architected. And so generally doesn't have loads and loads of messy data in it. It's actually very clean and well modeled. So that makes life a bit easier. I think then sort of taking that approach of like load it all into the lake and then use DBT to incrementally clean it up. I think the danger is where you have like hidden cleanup layers. So if you've got a cleanup layer sort of somewhere in the ingestion level that the analyst can't see, they're going to be like, well, why is, like in the source system it looks like this, but it ingested looks like this. Why is that? I can't understand that. So being able to see like where you make your changes. And often what I say to the analysts is like, understand the business process that's creating your data. So like if you're looking at, say, sign up data, literally go yourself and sign up to that product, go through every page yourself, and then look at where the data arrives in the database. So you fully understand how that data is captured. And then if there are data quality issues, so sometimes data quality issues are perceived data quality issues because they haven't understood the sign up, the process that's generating the data. Where it's not a perceived problem, it's a real problem, then address that either with the source system itself or put in a fix somewhere up the stream that's well documented.
I think what's really interesting to me is, particularly when I read the news and when I consider my own like energy suppliers, is actually smart meters, because there's a lot around them actually being a bit unreliable. And you touched on how you basically actually have Kraken under the hood to kind of help you ensure that data is actually high quality when it arrives in the lake. And I was wondering, like, how do you deal with challenges such as smart meters? And maybe you can also elaborate a bit more on what does Kraken exactly do?
Yeah, so I'll talk through what Kraken does, and then I'll address this, because I should have answered data quality with smart meters, because that is a very good example of where we don't control the data capture, and it can be really challenging. So Kraken is three parts. It's Kraken Customer, Kraken Field, and Kraken Flex. So Kraken Customer is the retail platform. It basically allows an energy supplier or utility in a regulated market to run their whole system. So literally everything from capturing meter readings all the way through to billing those meter readings. Customers get in touch, all of the customer contact, like any sort of APIs that are exposed to sort of front ends, all handled by, and then I won't touch on Flex and Field right now because I think for the smart meter question, they're less relevant. With smart meters, in most countries, the supplier doesn't look after the smart meter. So the smart meter is typically put in place either by the network owner, so like in London, it's UKPN. In Paris, it's Enedis. Like the company that looks after the networks sometimes looks after the smart meter. That's what happens in countries like France, I think, in Japan. And they collect the data from the smart meter. And they might collect that centrally. So they might put it all in one big database, and then the supplier can ask for it. And if they own the meter point, if they look after that meter point, they'll get the data. In the UK, it's different in that the supplier technically owns the meter, but the infrastructure to get the data from the meter to a sort of central hub is run by a company called the DCC. So it's centrally run, not by the supplier, not by the network operator, but by this company. And the construct in the UK is like every meter, like the data lives on the meter and you just request it. Nobody centrally stores that data. Whereas in other countries, you pull the data in, you clean it up, and you make a nice central database that you can then source out. So we've got this like weird system where in the UK, we're relying on these like not very reliable databases at the end of a not very reliable network to keep track of all our smart meter data. So we then request it from the DCC, we put it in our data store, and then we process it, and we use a lot of Databricks to process it because there's a lot of data. And that's where we then will fit in data quality. So we'll do anomaly detection, we'll do like infill reads, where we haven't got the data. We'll go and request reads where we've got a gap where we think the data is on the meter but it hasn't come to us. And that is a really hard problem. And it's a classic case of like, if you don't own the data capture, you're kind of beholden to the data capture system and you have to do the data quality solving downstream rather than at the source.
That's a really hard problem, actually. I was wondering, do you use any kind of AI and machine learning to handle that? Or I was wondering, like, what exactly do you do in that case?
It's actually nothing hugely fancy. So there is plenty of like AI built into Kraken in other places, but I think for the most part it's like simple anomaly detection. Like, you know, is the read much higher than the typical read for that meter? You could call that machine learning if you want. It's a sort of comparison of a reading to a mean, and then infill is like you're looking at like some sort of like baselining of previous periods to fill infill holes. So it's not like rocket science. It's actually the data engineering which is much harder in the smart meter processing space.
Yeah, I think that's really interesting because I guess I also come from like a data science background, and I think that as a data scientist with a good team of data engineers, you could be quite blessed because you don't understand just how much effort goes into the ingestion process and the cleaning process. I guess like when you're talking about, you have these business units and you have these pods, and is that why you have generally like different teams or having like a diverse range of different skill sets to kind of help? If you have a data scientist, they obviously need a data engineer there to help clean it up in the first place.
So we tend to have most of the engineers in the platform team because we want to do most of like the ingestion and the cleanup in that team and not have because that process is kind of the same for particularly the ingestion bit and the sort of staging is the same regardless of which department you're in. You could be in the electric vehicle department or you could be in the billing department of the retail business. It's always the same stuff. So we try and centralize that. The pods should then be what I'd call like full stack data professionals, I think is a better term. Data scientists and data analysts is quite a fuzzy spectrum. So I quite like sort of full stack data professionals. And what I mean by that is like they should be able to listen to the business owner, find a problem, figure out that problem, and they should be able to build the data assets that they need to answer that problem. And that data asset might be a whole new DBT table, it might be a new dashboard, it might be a machine learning model that you deploy, it might just be a graph that you do and stick in a Google Doc because you need to do it quickly, like whatever it is that solves the problem. And so the idea is the pods should be have high agency and be very close to the business problems. And then the platform team should be building tooling that enables that. So you don't have, when I look at some data organizations, they have the problem of like IT versus business. So the data analysts and data engineers live in the open source tools like dbt. In an ideal world, we should have like senior business leader speaking to data analyst and they solve the whole problem. And only when there's something like new ingestion or the platform's like something's broken, should we have to then go to the platform team.
I had a question about the interaction of business users with the data team. And what are some of the good practices of communicating results from the analysis to the business users? And do you believe in data democratization so the business users can interact with the data directly, maybe by leveraging generative AI and all these new techniques?
Yeah, so I'm a very firm believer in data democratization, although I think it's something that gets bandied around and it's hard to achieve and doesn't get and I don't think we've fully nailed it yet, but lots of people talk about it and then it actually doesn't happen. I told you earlier that we had over 600 Databricks platform users and a data team of 50 to 100 people, depending on how you count it. That means that we're 6-to-1 leveraged in terms of the number of people interacting with data at a Databricks platform level. So that might be dashboarding, or it might be using the SQL UI versus the people, the actual data professionals. So yeah, loads of people are basically using that data. And so I think we've sort of democratized that. And I think Gen AI will hopefully start to bridge that gap between I have a question and I need to write a query. The key enabler there is you have to make sure your data is in good shape and well documented, because if it's not, the AI is going to write a great query against the wrong table. Yeah. And then the communication thing, I'd love to talk about that one because I think it's really interesting and something maybe that falls down, particularly amongst junior data people I see that come in. They typically will focus on tooling. So they're I'm great, I can write the best DBT, I'm really good at SQL, I've nailed Git, I'm really good at Python. but they haven't focused on the other two ends of the data journey, which is like, can you synthesize the problem? Can you figure out like what actually the business is asking for? And can you communicate your results really effectively? So communication for me is like the magical trick that opens it up is to like imagine you're receiving the email rather than writing the email. So if I'm receiving that email, like what does that, like just look at it from that eye, like that axis doesn't make any sense, or like that's an ambiguous statement, or I haven't put enough information in here to actually describe what I did or where I got the data from. And as soon as you start flipping it and saying, what would the person I'm sending this to ask, as soon as you get that empathy with the person you're doing the data for, the quicker you get really good at communicating.
Again, like back to the fast-growing company side of things, I feel like this problem will get increasingly hard as you continue to grow. And like, how do you handle this when you have, for example, you have, like you mentioned, you have Kraken Field, Kraken Customer, all these different units. Do you do like knowledge sharing between business units to find out how you're solving similar problems? And do you even find this problem at the moment, actually?
We definitely do. I think we have like things like sort of central data science stand-ups and data help channels, which kind of helps so people can see what's coming in. Something we did recently, we find this problem particularly where we've got retail businesses in lots of countries, and they're all like, the UK has 6 million customers and it's a very mature energy retail business. Our US business is like thousands of customers and is like not as mature yet. They're going through a different journey, and I don't want them to solve problems like we solve problems, because we have to solve problems a bit slower because there's a lot more data and a lot more like customers in play, and like you can't take as many risks, I don't think, as when you're like super startup. But one challenge that was put to me was like, I don't know what the other regions are doing, and I don't know, like, surely someone's like solved this problem somewhere else. And we tried a meeting, but the meeting was everyone said their thing and nobody really, like, everybody was like, this is what I'm working on, and kind of no, you know, like you don't really listen when everyone's just like listing out what they're working on. I think we've pushed it forward recently. What I've done is ask for a shared roadmap. So in every like domain area, so write down what your country's doing, and then people can go and cherry pick from that. And we're going to publish that to the whole retail data organization, so they can go and be like, hey, I know Germany are looking at that thing. I might go and speak to them. And so I think of it like, so it's about bilateral collaboration, encouraging bilateral collaboration rather than encouraging centralized collaboration. The more you can get people to speak to each other and know what they're doing, better, rather than trying to centrally push out like, hey, you work with you, or try and do a one-size-fits-all solution across every region.
I find it really interesting because I guess like, how do you also encourage that also from even like an incentive structure? Because I guess coming from maybe some larger enterprises, it can be maybe almost competitive in large companies actually, when you have different teams and different units. And how do you ensure that collaboration is always positive and you're always encouraging like these positive behaviors?
That's a very good question. I think generally if you hire, we have less of an issue where we've got lots of competitive tension between businesses, particularly like, the German retail business. The UK really wants to see it grow, do well. So we want to help them. So I think we don't really have as much of a problem. If you hire like people with high EQs, they'll tend to resolve conflict rather than like create conflict. And I think the challenge comes when you're competing for resource. So say like 3 countries want something from different things from the data platform team, and then you need engineering managers again with like high EQs and the ability to like juggle, but also find the like quickest solution or like the common solution. Like, hey, what could we do here that like could solve everybody's problem?
Yeah, that totally makes sense. You clearly put like a huge emphasis actually on not just technical skills, but also all these soft skills, which is really interesting because I feel like in the past, tech was very much focused around the hard skills, and it's much more of like a modern trend towards this. One thing you did touch on there earlier was a little bit on generative AI. I'd just love to dig into that because it's so topical right now.
Like, not ask about it.
I guess like even just starting off, like how do you see it on the hype curve? Do you think it's overhyped? Do you think there's real business value immediately you can unlock? What's your kind of opinions on it?
So it's definitely, I think it's like simultaneously sort of Schrodinger's cat vibes of like, it's sort of simultaneously overhyped and extremely valuable from a business perspective. Like it is definitely adding lots of value. I can see it adding lots of value across our organization, but I also see a lot of hype out there, and being able to cut through the hype and figure out like what are the tools that really add value and what is somebody who's created a business, put a wrapper around an open AI API and is charging for that, like for that business. I think, and the way to solve that is to try and work like as low down the stack as possible. So build stuff on top of like foundational model APIs as opposed to buying lots and lots of wrapped services, because the models are moving so fast.
Are you able to share like what kind of business challenges, even at a high level, do you think that is most appropriate to solve right now? Because there's a lot of discussion around, issues of hallucinations and the other quirky parts of these models, and how do you kind of balance the benefits and the risks?
So I see it I sort of split it out when I talk about Gen AI. There's the enabling piece, which is like almost like an IT or a tech ops type challenge. Like Gen AI is going to be in every application on everyone's machines. And it's literally like Excel. When Excel came out, it's a new tool that anyone can use it's like a new Swiss Army knife. And then there's like Gen AI in product, where you embed your Gen AI into something you're building and serving to customers. So on the sort of like enabling generic side, it's obviously super powerful as like Copilot. Like we use a lot of GitHub Copilot. A lot of people use it just for day-to-day helping them answer questions and doing their job, particularly if they're writing a lot of code, because it's awesome at coding. I use it a lot when I'm hacking stuff together. And then on the product side, we speak to a lot of customers, like hundreds of thousands of customers a week. And so as a platform, Kraken is enabling utilities to speak to customers. And so having great Gen AI tooling in that makes a lot of sense. And so there's a few products that the Kraken team have built into it that help our energy specialists, our customer service teams, speak to customers and solve their problems quicker. So one is like summarization, which is awesome. So we can summarize a call, like a 7-minute call with a customer. If an energy specialist was coming back to that call to say what happened with that customer, they'd have to listen to 7 minutes of audio. We just transcribe it and summarize it, and so they can read 30 seconds of reading gets them that they get 6.5 minutes back, and then we can do the same with long threads. So if they've like long messaging threads, we can do the same, like what's going on. We do sort of message generation assistance. So where the energy specialist is like, can you just write a quick response confirming this thing? It will take all of the context, all of our knowledge bases, and help the energy and basically generate a message in the right tone of voice for the energy specialist. Always check before it goes out. And now we're moving into what I'd call like automated response and action. And so that is like taking a custom message saying, actually, I know what this is, I know how to solve it. Generating a response, again, not automated, we'll check that it's okay. And generating an action plan. So it might be process this meter reading and issue a bill. And here are the 2 buttons to do that. And so the Kraken team are building that in as well. So yeah, I think it's got like huge potential. And I think voice, I've seen a few demos recently where voice is like, the latency on the conversation is coming down a lot, and the ability to handle like interruptions and just like the general complexity of a human conversation is coming down. So like voice is coming fast, and God only knows what that means for customer service companies.
Fantastic. And the question about check-in response that was generated by the model, what is your approach there? Do you have like a human in the loop? Are you looking into LLM as a judge? Because I think human in the loop is great to have, but it doesn't scale too much. So what are your thoughts about it?
So we're using human in the loop. The idea is that the Gen AI is, if I take a step back, Octopus is founds ourselves on like amazing customer service. And we in the UK have been like, I think 7 years in a row or 6 years in a row, the only Which recommended energy provider. We really like love and are passionate about going above and beyond for customers. And so we'll always want humans to help customers with like their difficult problems. Because often an energy problem, energy is like one of the biggest bills you pay. And often an energy problem can be extremely distressing or hard. Like if you go into debt, if you can't pay your bills, if your prepay meters cut you off and you no longer have heating, like that's a really difficult personal problem that you don't want to speak to a robot for. You want a human to solve it, and you want them to do it with like amazing empathy, and maybe go above and beyond, like a little gesture to like make them feel loved and and appreciated. And robots are not, AIs are not going to be able to do that. Maybe they'll be able to sort of emulate that, but they won't be able to emulate it in a way that's sort of like real and like generate. So the idea is we're building Gen AI tools that make our energy specialists more superhuman. And when we started Kraken, that was the whole point of Kraken. Before the Gen AI trend, the idea was like they have everything at their fingertips to be able to answer a customer question. So when you called up a traditional energy supplier, you would get like, I've got a payment issue, and they go, okay, let me transfer you to the payments team. And it actually turned out that payments issue was a billing issue. So you get kicked onto the billing team. And like you've spoken to 3 people, maybe taken like an hour, and maybe no one solved your problem because they've kicked it over to the back office team who have to action the thing later on. And so the whole idea with Kraken was like, it's a one-stop shop. The energy specialist is empowered to solve your whole problem because the platform does everything. And that was a case of like using technology to make an energy specialist superhuman. And we think Gen AI is just the next layer on top of that. There will be some stuff we can automate, but we still want that like human
interaction. That makes sense. I've never thought about it. And it's actually like, you have some other service providers and being kind of kicked from, as you said, billing team to back office can be so frustrating. So, and yeah, great to hear that you're challenging this approach.
Very interesting because it's the paradigm of like designing your customer journey around your systems, which makes like, if you start a startup now, you never design your customer journey around your systems. You design your customer journey in a way that is like the best for the customer, and then you build your systems to deliver that. But legacy businesses, for whatever reason, design their customer journey around their source systems, which is just like putting the cart before the horse, I think.
But actually, one thing I did want to ask a little bit was like your journey to the field, like to data in particular, because I think you actually have an energy background. But I was wondering if you kind of share like how you ended up at Octopus and just a little bit around that.
Yeah, so I'm like, maybe I call myself like a sort of data mongrel. I haven't come from a sort of like algorithmic PhD machine learning background, nor have I come from a software engineering background. I've sort of taught myself those domains. I worked in energy trading for BP for a few years, and there I kind of fell in love with like the energy system. I think it's like unbelievably fascinating, this like complex web of infrastructure, markets, people that delivers what we take for granted, but like keeping a grid on and keeping everyone's cars fueled up all the time at quite a low cost is an amazing feat of like both physical engineering, economic engineering, and like human engineering. And I really like loved being part of that. So I loved energy. I wanted to be sort of closer to the action within BP, so closer to sort of like the hardware. So I then moved into reservoir modeling. So I was like doing computational modeling to figure out how you get oil out of the ground. And there people were doing you have to run like lots of simulations. So it's like lots of Monte Carlo simulations to figure out like, because there's so much uncertainty because you're trying to work out what's going on like thousands of meters under the ground. And no one really knows. All you've done is like poke a few holes in it. And then like that's your information. You've poked a few holes, you've like sent some seismic sound down and looked at the reflections, and that is your understanding. And you're then trying to plan like exactly how to deploy hundreds of millions of pounds worth of capital to go and extract that oil. So you end up running loads and loads of simulations. And in that role, people were like doing them one by one. You have to, like, a simulation is effectively a computer program that you run in a sort of Linux machine. And they were doing them one by one. And I was like, why don't we just like batch these up? So I started hacking together Python scripts. And then I was like hacking together sort of like databasey type like results formats and then sticking BI tools on top. And I was like, this is fun. I'm quite enjoying like building these databases, but I had no idea like what else was out there. I also had a sneaking suspicion that like the oil and gas sector probably wasn't like morally the place I wanted to spend the rest of my career. And so I started looking around for jobs in tech and clean tech, and I found Octopus, and I had a meeting with the founders, and they told me this compelling story about kind of a lot of stuff I described, which is like using technology to both drive a customer-led transition and also like do it in a way that's like great for the customer. And so I sort of took a punt, left an enormous company to join a 20-person company, built all of our like pricing and commercial models. So we like did a bunch of work figuring out where should we price. That was the first question I answered, like where should we price our energy to be competitive but also cost effective. And then from there, built out a lot of our analytics stack, and then hired a load of people who are like way more technical and better than me, and have built a team from there. So that's my journey into it, which I think is like, so I would say I come from more of a business and energy background. I spend a lot of my evenings trying to backfill knowledge. My philosophy is like, I should be able to roughly do what like most people in the team, or at least understand it. So like, certainly there's bits of like the Kubernetes stack that we use that I have like very little clue, but at least like I'll have a crack at like running a little mini kube machine on my machine once just to understand the concepts. Because I think if you get to a place in an organization where your leaders don't understand the day-to-day jobs of what's going on, you end up with like really disjointed decision making. So I'll like annoy my team by like taking on little bits of work or like asking them stupid technical questions, but that allows me to remain technologically sharp, I think.
When you talked about energy trading, I just remembered the movie Enron, The Smartest Guys in the Room. I don't know, have you seen it?
I've read the book, yeah.
Well, I guess it's good to see like companies like Octopus Energy and data leaders like yourself who have like the opposite principles from that crowd.
The energy sector is often painted as like the evil versus and obviously Enron, there was like massive corporate failings and some like really nefarious behavior driven by some very bad incentive structures that led to like some really bad outcomes. But in the energy sector, generally, it is full, regardless if you're working on like the oil and gas side. A lot of the people I work with VP are like amazing, super smart, want to do the right thing, or like the clean energy side. Like the energy sector is full of like really incredible, passionate people. And I think the key is, for us, we see the goal is like to try and lead that sector to do the right thing. And sometimes that means, there's a lot of received wisdom in the energy sector as well, because it's been around for so long and it works. Like there's like stuff you get, like we have petrol in our cars and lights in this room, but being able to show that there is a different way to do it. Like you can, customers can be paid to turn down. We don't have to spend billions of pounds like turning up a nuclear power station. That's the key. And technology is like obviously central to that.
I also have a final question. I remember from earlier. It's a hard one though.
Harder than the Enron one.
It's actually easier. It's back to the topic we can't avoid, which is Gen AI, because I find it really interesting when you're describing about having a human in the loop system, because it's perhaps particularly topical given the recent case with Canada Air and the refund policy. And I guess one thing I'd like to understand is, although you have a human in the loop, they can sometimes perhaps get fatigued or overly confident if they're just, for example, checking if a response is appropriate or not. And how are you going to handle that in the context of perhaps if a customer asks about a refund policy? How do you handle that automatic message generation?
Yeah, it's a problem. There's some amazing stories coming. I like the Chrysler one about the chatbot, which was just a sort of thin wrap around OpenAI, and you could just use it as a cheap OpenAI. There's stuff you have to guard against, and definitely like the fatigue or the lack of checking is a really important one. And then that can cascade into Gen AI making up your company policies for you. One of the things one of the engineers came up with, which was really smart, was this idea of like edit distance checking. So we check the edit distance between the message the energy specialist ends up sending and the message that gets generated. And so if you systematically look at that, you'll find the energy specialists who are not making any meaningful changes to the messages. But also like this stuff, you catch this stuff fast. Like Greg is amazing in that he reads a lot of customer emails and gets a lot of escalations and answers them all on social media. Greg, the CEO of Octopus, and that culture of like right at the very top level, still interacting with customers, means you catch this stuff fast. So like the management team of Octopus have an amazing nose for when something's going wrong, because they're speaking to customers on a daily basis. And so if you have systemic issues, which we defend against, as long as you catch them fast and then rectify them, that's good.
That's really cool. I'll say thank you very much then for listening to the first episode of the Digital Natives podcast, and for our guest David for being our first guest.
Yes, David, thanks so much.
Thank you for having me.